Good morning, everyone. So today we're going to finally talk about p-value, which I'm super excited about because a lot of these chi-square hypothesis testing conclusions are actually reached with the p-value. Now, if you remember, when we put our data into the calculator, you're going to get the chi-square calculated value, you get a p-value, and you get a degrees of freedom. So let's talk a little bit about what p-value is. P-value is the area under the curve. Okay, so it's based on probability theory, like I told you. Notice here's my curve. So the area under the entire curve is 1, or 100% of the data basically fits under this curve. If we have a 5% significance level, then my cutoff is 0.05. Now, if I say p-value is area under the curve, underneath this chunk right here, which is the biggest, right? This would be the 0.95. So 95% of the data falls into this big chunk right here that's going to be shaded. And anything that's less than 5% is going to be in this non-shaded part. Because if you think about this in terms of here's my axis, we're talking about the space that the graph creates to this axis. My lines are horrible because I'm doing them on with the mouse. So then you're going to look at the curve. So as the curve's tail right here goes further and further, that space between the tail of the curve of the graph and the actual coordinate, like the axis, gets smaller and smaller and smaller. So the thing about p-value is that the bigger the number, the more into the shaded part it goes. It's opposite of what a normal number line works. So in a normal number line, the bigger the number, it goes to the right. The smaller the number, it goes to the left. But this is opposite because we're talking about area under the curve. So we're going to take a look at the two examples that we already did in class. The first one was the whole thing with the gender and level of teaching, if you remember. So take your calculator right now, and we're going to input, excuse me, go to matrix, second x to the -1, go over to edit, press enter. You're going to type in the size of this matrix, which is a 2x3 matrix. So 2, enter, 3, enter. I would show you on the calculator, but it's not working. The one that I used in the class, so sorry. And then you're going to put the observed values, which here are 10, 15. It looks like, let me erase. So 10, 15, 25. After each number, you got to press enter. 20, 15, 15. That's literally as complicated as it gets. That's going to give you a p-value, and right away, you're going to be able to make a conclusion. You don't even need to do any calculations in order for you to use p-value to make a conclusion. So sometimes on the exam, they won't even give you a calculated or critical value because you can just get p-value and get the answer right away. So then remember, we go to stat, we go over to test. This is a chi-square test of independence. You use option C, and then you press enter, enter, enter. And then it's going to give you the chi-square calculated value of 5.83, which is what we did when we did the full phi chart. If you remember, full phi, full minus phi squared, full minus phi squared divided by phi. That gave me the chi-square calculated value of 5.83. We found the chi-square critical value from the chart that we used to figure it out. And we were able to make our conclusion that way. But right now, just by putting in the data into the calculator and going stat test, I also get what's called a p-value. So right now in the calculator, the p-value is 0.05. This is hard to do with the mouse. 41. Okay, so 0.0541 to 3 significant figures. That's the p-value. Now we are going to make a conclusion based on the p-value versus the significance level. 0.0541 is bigger than 0.05, not by a lot, by a little bit. This is 5%, this is 5.41%. So the p-value here is greater than the significance level of 0.05, meaning the p-value is somewhere here because it covers more area than the 5%. So 5.41% is going to cover more area. So the p-value is right here, somewhere to the left, 0.0541, because remember, it is bigger, so it covers more area, so it goes in the shaded region. So because it goes into the shaded region, then we say that we accept the null hypothesis But remember, the correct way that we're going to say accept in statistics is fail to reject, okay? So we are going to quote unquote accept the null hypothesis, which basically means that we're going to reject, that we're going to accept, so we're going to fail to reject the null hypothesis, okay? So since the p-value is greater than the significance level, the alpha level of 5%, then we accept the null hypothesis because in the shaded region, which means we fail to reject the null hypothesis, and conclude that gender and level of teaching are independent. Since we are failing to reject, we're accepting, we're saying that yes, they are independent, they have nothing to do with each other. We already did this problem, and we made our conclusion based on chi-square calculated versus chi-square critical. The result that we got there and the result that we get now with p-value is exactly the same. It's always going to be exactly the same. You're never going to get one way of writing the conclusion where you accept and then the other one you reject. You're going to end up with the same conclusion. P-value is just a lot faster. So sometimes they're not going to give you a critical value on the exam. They're just going to give you the data. And with that, you put it into the matrix and you can quickly figure out the p-value and make a conclusion based on that result. Let's take a look at the next one, okay? The next problem that we did was the problem about ethnicity and seatbelt usage. Let's take the calculator again. Go back to your matrix, second x to the -1. Go over to edit, press enter for matrix A, and this is a 2x2 matrix, okay? So now you're gonna enter the values 31, 148, 283, 330. We already had the rest of this filled out, but pretend we didn't. Pretend we didn't have it all filled out, and we're ready to just make a conclusion based on these numbers. You're going to go to stat, you're going to go to test, you're going to go up to chi-square, option C, and you just press enter until you get the answer. And if you remembered here, the chi-square calculated value was 48.2, which the calculator gives you. And then the p-value in this case, it says that it is 3.88 because it's 3.87855. Okay, so I'm going to write this down. I'm going to write down what the calculator gives me for the p-value. The p-value is 3.878556987 e -12. You need to understand what that e -12 means. You will never write that down either on your IA or on the exam itself. It will never be accepted as an answer. That e means scientific notation. So in reality, this number is just 3.88 times 10 to the -12th power. That's what that number means. That's how you would write your answer to three significant figures, okay? When you have 3.88 times 10 to the -12, that means that you would take that decimal, the 3, that's after the 3 right now, and you would move it to the left 12 times. So basically this would be 0.000000000388. That number is tiny, tiny, okay? So in terms of area under the curve, it's a very, very little tiny amount of area. So it's going to be way out here. So right now, this p-value is way out in the far right because the area is so tiny. So 3.88 is like a challenge here. Times 10 to the -12 is going to go way out here. And if you look at your notes, when we did this in terms of chi-square calculated versus chi-square critical, the same thing happened with the chi-square calculated. It was like 48.2, which was way bigger than the cutoff, which was the critical value of 3.841. So how do I write my conclusion? Since the p-value of, here I go again, 3.88 times 10 to the -12 is less than, it's smaller, way smaller than the significance level of 0.05, then we reject the null hypothesis, because remember, it's definitely in the rejection region, and conclude that ethnicity and seatbelt usage are not independent. Okay, so that's how p-value works. So again, p-value is area under the curve. The bigger the number, the more into the shaded part it is. The smaller the number, the more into the rejection region it is. The conclusion looks exactly the same. Notice this is literally what I haven't put in an underline. Those are the parts that never change in your conclusion. What changes are the values, and then whether you are accepting or rejecting based on whether it's smaller or bigger. And then you restate your conclusion. If you reject, they are not independent. If you accept, which means you fail to reject, then they are independent. Okay? So that's everything that you need to know in terms of p-value. Be careful in the calculator because some people literally just look at it and go, oh, it's 3.88, and you would have totally gotten the wrong answer. If you see an E, it's not decoration. It's because it's scientific notation. So basically, that's it for p-value. It's another way of coming up with conclusions, and it's super easy because we don't really have to do many other calculations. So you need to understand p-value. Bye.